Hello and welcome. We are going to start today by talking about Chapter 6, which are additional topics in trigonometry. This will be our last chapter covering trigonometry this year. We're going to start with Section 6.1 today, and that's the law of sines, and we will continue 6.1 tomorrow as well. So first, what is the law of sines? The law of sines is a formula which tells us about the relationship between the parts of any triangle. So you can see I've got a triangle here called triangle ABC. The angles are always represented with capital letters, and then the side lengths are always going to be the lowercase letters that are opposite that angle. So there's angle A, there's side length A. And the formula for this triangle is that side length A divided by the sine of angle A, so this side length divided by the sine of this angle, will be equal to side length B divided by the sine of angle B, which is this side length divided by this angle, and that will also be equal to side length C divided by angle C. The law of sines is useful in these cases when you know angle, side, angle, or angle, angle, side. That is two angles like A and C and their included sides, so the side that's in between them. Or two angles, let's say angle A and angle C, and either one of these sides. So basically anytime you know two angles, the law of sines is going to be helpful. And what the law of sines can do is it can help you solve triangles. When you're being asked to solve a triangle, what that means is it's asking you to find all missing parts of the triangle. So that means find all the sides and angles of the triangle. Find all missing parts. So if I have triangle ABC, and I know angle A is 40 degrees, angle B is 59 degrees, angle C is side length C is 14 units, find the missing parts of the triangle. So what I'm going to do is I'm going to draw what I know about this triangle. So just drawing a triangle there, label it triangle ABC, and label the parts you know. Angle A is 40 degrees. Angle B is 59 degrees. Side length C, because it's a lowercase c, is 14 units. And now what I want to do is I want to find these missing parts, all the missing sides and the missing angle. The easiest of those to find is this missing angle right here, angle C, because we should know that all the angles in a triangle add up to 180 degrees. So all I have to do is subtract from 180, and I will get 81 when I do that, which means angle C is 81 degrees, and there's one of my missing parts that I have found, 81 degrees. Next, the other missing parts I need to find would be side length A and side length B. And to find those, I need to use the law of sines. And the law of sines says that side length A is equal to the sine of angle A, which is 40 degrees, is equal to side length B divided by the sine of angle B, which is 59 degrees, is equal to side length C, which is 14, over the sine of angle C, which we already found to be 81 degrees. And you'll notice I can't really solve this equation because, well, it's got two equal signs and two variables. But what I'm going to do is I'm going to take this equation that has three fractions equal to each other, and I'm basically going to pick just two of these fractions to write down that are equal to each other. And I'm going to start with the one that uses side length A. Side length A divided by the sine of 40 degrees is equal to, and now setting it equal to this middle fraction right here would be a pretty bad idea because then I'd have an equation with two variables in it. Instead, I want to set it equal to this fraction right here because I know all the numbers in this third fraction here. And now I've got an equation here with only one variable in it. And now I'm going to solve this equation. And the way you can do that easily in one step to get A alone is multiply both sides of the equation by the sine of 40 degrees, because that will get rid of that denominator right there, and you're left with side length A is equal to 14 times the sine of 40 degrees over the sine of 81 degrees. And then you can type that all into your calculator at once. Make sure that your calculator is in degrees. So go mode, go over, make sure the degrees are selected. And you can just type in 14 times the sine of 40 degrees divided by the sine of 81 degrees. And there's your answer right there. We're going to round to the nearest tenth, and that's 9.1. So that tells us that side length A is 9.1 units. I'm then going to do something very similar for side length B. I'm going to take this fraction right here, B divided by the sine of 59 degrees is equal to, and then I'm going to set it equal to this fraction here where I know both the numbers already. And then I solve this equation in much the same way that I solved the previous one. I'm going to get B alone by multiplying both the left and right side of the equation by the sine of 59 degrees, which will cancel that denominator right there. And I'll be left with B equals 14 times the sine of 59 degrees divided by the sine of 81 degrees. I can then type that into my calculator. 14 times the sine of 59 degrees divided by the sine of 81 degrees, and I get about 12.1. So that tells me that side length B is 12.1 units. So there's my answer right there. Those are the missing parts of the triangle, and I have now solved the triangle because I found all the missing parts. Now I'd like you to go ahead and try one. So solve this triangle. ABC, if angle A is 64 degrees, angle C is 82 degrees, and side length C is 25. Round your measures to the nearest tenth. Go ahead, draw that triangle, label the parts, and use the law of sines to find all the missing parts. You can go ahead and press pause on this video and then press play when you're ready to see the answer. Okay, so let's check to see what you got. There's my triangle, and there are the missing parts of the triangle. And here is my work for those missing parts. Started with that angle, then use the law of sines to set that up and find the missing part. Set the law of sines to find that missing part. Next, we're going to get into a little more complicated example here. You can see a little more complicated diagram here where we've got some overlapping triangles here. My goal in this one is to find this side length to the nearest tenth, and here's the information that I'm given. So I'm going to start by basically just labeling this information on my diagram. Segment AB is 78, so that's between A and B is 78. Angle A right here is 32 degrees. And then angle DBC. Angle DBC is this angle right here, and that's going to be 50 degrees. Now, based on that information, my goal is to try to find this height right here. First thing I'm going to do is I'm going to start finding some missing angles in this diagram. One angle you can find right away is this one right here, because from here to here is 180 degrees, so just subtract out that 50 and you'll be left with that being a 130 degree angle right there. Next thing I'm going to do is find this angle right here, because you can see that's a part of a triangle, and all three of these angles need to add up to 180. So I can do 180 minus this right angle here is 90 degrees, minus this angle right here is 50 degrees, and that leaves me with 40 degrees for that angle right there. Next thing I can do is I can find this angle right here because that's a part of this triangle, and I know two of the angles already, and all three of them are going to add up to 180. So I can do 180 minus 130 minus 32, and that leaves me with 18 degrees right there. So next what I'm going to do is I'm going to start finding some missing side lengths. And the way I'm going to do that is I'm going to use this triangle right here. That's triangle DBA. I'm going to use this triangle right here in which I know all three angles, and I'm going to use that to find side length X. And the way I'm going to do that is I'm going to set up the law of sines. Side length X here is opposite this 32-degree angle. And that's equal to, and then I'm going to use the side length of this triangle that I know. That side length AB here is 78 over the sine of that angle right there that's opposite that side length of 78 is 18 degrees. And then to solve this, I multiply both sides by that denominator to get rid of that denominator over on this side. I multiply this side by sine 32 degrees. So X is 78 times the sine of 32 degrees over the sine of 18 degrees. You can type that into your calculator and get that it is approximately equal to 133.8. So this piece right here is 133.8. Now, the reason I did that is because I now know one of the side lengths of this triangle right here. Okay? Now that I know all three of the angles of this triangle and one of the side lengths, I can use that to find that missing side length right there. And basically, I'm going to show you two options of how to do that. One way you can do that is using the law of sines that we've been learning. I can say, okay, side length H is equal to divided by the angle opposite. Side length H is sine 50 degrees equals, and then I'm going to use the side length that I know, 133.8 over the sine of this angle right here that's opposite that 133.8 is sine 90 degrees. And then I solve this the same way I've been solving them. I did multiply, that gets rid of that, and I'm left with H is equal to 133.8 times the sine of 50 degrees divided by the sine of 90 degrees. Type that into your calculator and you get that H is 102.5, and that's what I was looking for. Another way to do this last step is to recognize the fact that we're actually working with a right triangle, and we know other stuff about right triangles. You might have been thinking this whole time, why aren't we using like the Pythagorean theorem to find things or SOHCAHTOA to find things? Well, that's because those things only work when you have right triangles. Since we do have a right triangle, I can use SOHCAHTOA, which says that the sine of an angle, this angle right here is the angle I'm going to use, 50 degrees, is equal to the opposite side divided by the hypotenuse. That's why I'm choosing sine, because I want the opposite side and I know the hypotenuse. So the opposite side is H, the hypotenuse is 133.8, and then to solve this I just need to multiply both sides by 133.8. To do that, that'll cancel, and 133.8 times the sine of 50 degrees will also be equal to 102.5. And you might notice the reason that's true, because that's our numerator here, that's because the sine of 90 degrees is equal to 1. So really we're dividing by 1 here. So if you got a right triangle, you can still use that old stuff, you know.